In this video, I am going to start a new chapter, that is structure of molecules. Let's first do the introduction. The attractive force that keeps the atoms together in a substance is called bond. Let us take the example of water molecule. According to the definition, attraction that is keeping them together is known as bond. There are many other examples as well. So, when atoms are held together in a molecule, then there is attraction force between them, and that attraction is known as bond. Atoms combine with one another by process called chemical bonding. We call it bond, and the process by which it combines, this process is known as chemical bonding. Now the question arises, why do atoms form chemical bonds? In this world, everything has the tendency to lower its energy. Let us understand with the help of examples. Now let us take the example of water. From a hill, the water is coming downward. At the top of the hill, the water has high potential, and down it has low potential. So water is moving from high potential to low potential. Here are some other examples. We all know that diffusion is the movement of molecules from the higher concentration to lower concentration. So diffusion is also happening from higher to lower concentration. The other example is hot cup of coffee on table. Now what happens when we place a hot cup of coffee on the table? In this case, what happens? The coffee gets colder over time. So heat is transferred from the hot body, that is cup of coffee, to the cold body. So now they say that atoms also have a tendency to decrease their energy. They do so by combining with other atoms. How atoms decrease their energy? They do so by combining with other atoms. Now, every atom wants to become stable. Why they are decreasing their energy? To attain stability. Now, how atom attain stability? To attain stability, atoms either lose, gain or share electrons to complete the valence shell electrons. They want to complete their valence shell, but how they complete their valence shell? By losing, gaining or sharing of electrons. Get the noble gas electronic configuration. Now here I took two examples from the noble gases, that is helium and neon. Helium has only 2 electrons, so its octet is complete, and neon, it has 2 electrons in its first shell. Second shell has 8 electrons. It means that helium's outer shell is complete and the neon's valence shell is also complete. It has 8 valence electrons. Similarly, all the noble gases have complete valence shell. Noble gases are stable and non-reactive because of a stable electronic configuration. Why they are stable? Because their valence shell is complete. And why they are non-reactive? Because they do not need to lose or gain electron. Their valence shells are already complete. They do not need to lose or gain electrons, hence they are non-reactive and stable. Now let us see how other atoms lose, gain or share electrons in order to attain stability. Now here we have sodium. In the first shell, it has 2 electrons, in the second it has 8 electrons, and in the third shell it has only 1 electron. So if sodium will lose its 1 electron, it will attain the noble gas electronic configuration. It will have the 8 electrons in its valence shell. Now we are taking the chlorine atom. Have a look. It has 2 electrons in its first shell, 8 electrons in the second shell, and 7 electrons in its valence shell. Now if this chlorine will gain an electron, it will have the 8 electrons in its valence shell. Now what will happen over here? The sodium will lose its electron and the chlorine will gain that electron. By the loss of electron, sodium will get the noble gas electronic configuration, and by the gain of electron, chlorine will also get the noble gas electronic configuration. Now a bond will be formed between them, and that bond is called ionic bond. So now it became stable by the losing of electron by the sodium and the gaining of electron by the chlorine atom.